So we've built these 4 circuits. Before we take our measurements and our observations about them, we need to predict what we think we're going to see, because that will prepare our minds for what we need to learn about this topic. So you need to predict which of these 4 circuits is going to have the LED shining brightest. Which one's going to have the LED second brightest, third brightest, and the dimmest. You should pause this movie now and try this yourself before you continue. Let's take the circuits 2 by 2 and compare them. Let's start by comparing circuit 1 with circuit 2. The first step is to simplify the circuit so that it's easier to compare. And you should realize that meters, ammeters, and voltmeters have no effect on the circuit. And so we can remove them when we think about which one is going to be brightest. Because a meter's job is just to measure, it's not to affect. If a meter actually affects a circuit, there's something wrong with it. So let's take those meters out, and then we have a simpler circuit for circuit 1 and for circuit 2. And then it's easier to think about the circuits and compare them. So which LED is going to shine brighter? This one in circuit 1 or this one in circuit 2? And why do you say so? Let's see what's the same and what is different about these 2 circuits. They both have the same potential difference across the circuit. In other words, the total voltage supplied is the same in both cases. They both have an LED, but where they are different is the resistor which is in series with the LED, the resistance of that resistor. In circuit 1, the resistance is only 1 kilo ohm, whereas in circuit 2, it's 22 times more than that. Now, I'm not drawing this R 22 times bigger because that's a little difficult to do, but by writing the R big, I'm meaning that the resistance of that resistor is a lot more than the resistance of the 1K. Resistance means the opposition to flow of electric current. How difficult that component makes it for electric current to flow. So how is this difference between the 2 circuits going to affect other things about the 2 circuits? What about current strength? In both circuits, the potential difference pushing the current around the circuit is the same, 9 volt, supplied by the battery. But in circuit 1, it's easier for the current to flow because there's a low resistance, only 1K and the LED. Whereas in circuit 2, it's more difficult for the current to flow because the 22K resistor makes it more difficult. There's a higher resistance. So in circuit 1, we're going to get a higher current strength flowing through the circuit than we are going to get in circuit 2. Remember that in a series circuit, the current strength is the same throughout the series circuit. So at all points in this circuit, there's the same high, relatively high current strength, and through all points of this circuit, there's the same relatively low current strength. Now the LED is the part of the circuit that we're particularly interested in because it's the LED's brightnesses we are comparing. So here, this is what's important here, that the current strength through the LED is greater in circuit 1 than in circuit 2. Now remember that power is the rate at which energy is transferred. So it tells us how much energy comes out in the form of heat and light from a bulb or LED per second. The more that comes out per second, the brighter. The more power is dissipated through an LED, the brighter. So we need to determine through which LED is more power dissipated so that we can predict which one will be brighter. Power equals energy per time. But this formula is not helpful for us in this particular situation because we don't know how much energy is coming out per how much time. This formula will help us. Power is equal to potential difference multiplied by current strength. Potential difference across the LED multiplied by the current strength through the LED will tell us the power dissipated through the LED. So we have already seen that a greater current strength flows through the LED in circuit 1 than in circuit 2. But to predict which one is going to be brighter, we actually need to be able to compare both the current strengths and the potential differences across the LED. So let's think about that for a moment. In both circuits, the battery gives 9 volt to the circuit. That 9 volt must be shared in each case, between the two components, the LED and the resistor. How that is shared is determined by the ratio of the resistances. Now, an LED is actually a non-ohmic conductor, so we cannot really pinpoint what its resistance is. But for the purposes of prediction, it will give us the right answer if we assume that it is actually an ohmic conductor, just for a while. In other words, that its resistance is constant. Now, we don't know what that resistance is, but let's just make it this particular size of R. So I'm trying to make those two R's have the same size as one another, indicating it's the same LED, same kind of LED, they have the same resistance as one another. Now, the ratio of the resistances in circuit 1 and the ratio of the resistances in circuit 2 is not the same ratio. We can see that in circuit 2, the ratio lies more heavily on the side of the 22K than what it lies for circuit 1 on the side of the 1K. That means that the voltage across the 22K is going to be greater than the voltage across the 1K. In both cases, the voltage across the two components must add up to 9 volts because that is what the battery supplies. So there's 9 volt available. So let's make 9 volts V size to be like that. Try to make them look the same. So the 9 volt is supplied. The 22K takes quite a lot of that away, leaving only a bit for the LED. Those two sizes are meant to add up to this size. The 1K doesn't take as much away as the 22K took, leaving more for the LED. So these two are meant to add up to that size there. So what have we seen from this? The potential difference across the LED in circuit 1 is greater than that in circuit 2, because circuit 2's LED is with a greedier resistor than circuit 1's LED is. And so in circuit 1, more of the voltage is given to the LED because less is taken by a greedy resistor than is the case in circuit 2. In circuit 2, not so much gets to the LED because the greedy resistor takes most of that which is supplied by the battery. So circuit 1's LED has both a greater potential difference across it and a higher current strength through it than circuit 2's LED does. And so when you multiply V multiplied by I, you're going to get a bigger power value in circuit 1 than you are in circuit 2. And so the LED is going to shine brighter for circuit 1 than for circuit 2. So here I have the circuits in the dark so that you can see more clearly. This is circuit 1, this is circuit 2. And let's connect circuit 1 and see how brightly the LED shines. Can you see that's pretty bright? Connect circuit 2 and can you see it's quite a lot dimmer?